Voltage. Depending on the circumstance, voltage can be calculated through the use of Ohm's law, KVL, or the voltage divider rule. Ohm's law, first of all, describes the relationship between current, voltage, and resistance, stating that voltage is directly proportional to current and resistance, assuming either one remains constant. The equation which details this relationship is simply just V equals IR, as seen here. Ohm's law is a fundamental link between electrical quantities, allowing for the user to calculate the voltage drops across any individual component. Next is KVL, or Kirchhoff's voltage law, which states that the sum of all changes in voltage around a closed loop within a circuit must equal zero. This law is based off the principle of the conservation of energy, using it to analyze circuits in both parallel and series configurations. Ohm's law can be used to find the actual values across components. Well, yeah. KVL provides a much bigger perspective, a much bigger picture perspective on the relationship between all voltages within a loop, which helps to solve for missing voltages when multiple components interact with one another. Finally, voltage divider rule describes how the total voltage of a circuit in series is divided proportionally among components in accordance with their respective resistances, allowing for the output voltages of across any components to be calculated. This is a more simplistic and efficient method of finding the output voltages by removing the need to also find the total current, resulting in being overall a highly practical tool. Voltage in capacitors and inductors. In an inductor, voltage is not stored, but rather is induced by the rate of change of entering current. Quicker changes in current induce a stronger voltage, which opposes the rate of change of current. As the current approaches its maximum value in the inductor, the induced voltage decreases until it is no longer present. Alternatively, in a capacitor, voltage is directly proportional to the charge it stores within the capacitor. This isn't The voltage changed as it needs to be first charged, reaching its capacity after more than five. Reaching the capacitor reaches capacity after more than 5 time constants. AC and DC voltages. DC is a form of monodirectional voltage that is constant over time, unchanging in its direction or magnitude. A common example would be a 9-volt battery, where one terminal remains at a positive 9-volt potential difference and the other zero, with electrons flowing from negative to positive. AC, unlike DC, is constantly changing its polarity and magnitude, periodically alternating between positive and negative values. AC is commonly used in power transmission as it reduces energy losses during long distances, as the high voltage allows for low current, reducing energy loss through heat. RMS can be used to find the effective DC voltage that would deliver the same amount of energy as an AC power source.